inequalities, where in our previous class we talked about range of values of combined inequalities, where we combined two different inequalities into a single inequality. And today we'll be talking about solution of simultaneous inequalities. Now we'll be solving two examples. The first example says, show on a graph the region that contains the solutions of the simultaneous inequalities 2x plus 3y less than 6, y minus 2x less than or equals to 2, and y greater than or equals to 0. Now, we have these numbers, we have these inequalities, 2x plus 3y less than 6, y minus 2x less than or equals to 2, and y greater than or equals to 0. Now, the first inequality would be written as 2x plus 3y less than 6, where we make y the subject of the formula. So we have 3y less than 6 minus 2x, and we have y to be less than 6 minus 2x over 3, where we can easily write it as y less than 1 over 3 into bracket 6 minus 2x. Now, it is important to know that y less than 1 over 3, 6 minus 2x is a boundary line. It is a boundary line. So we need to first when x is 0 and y is 0 for this. So where x is 0, what is y? So our y is less than 2, where y is equals to 1 over 3 is bracket 6 minus 2x, where x is 0, our y is 2. Now, where our y is 0, where we have 3y less than 6 minus 2x, where our y is 0, so we have 3y equals to 6 minus 2x. So we can have it to be 2x equals to 6 minus 3y. So we have 2x to be 6 minus 0. We have our 2x to be 6. So we have our x to be 6 over 2. We have our x to be 3. Now, where y is 0, our x is 3. Now, point below the broken line is now known as where x is 0, our y is 2. So we have it to be 0, 2. And where x is 3, our y is 0, we have it to be 3, 0. That is the first part. That is for the points which satisfy the inequality of 2x plus 3y less than 6. Similarly, for our inequality of y minus 2x less than or equals to 0, less than or equals to 2, where we have y to be 2 plus 2x. So we have y to be, when x is 0, we have y to be 2. And where y is 0, where x is 0, we have 2. Where y is 0, then we have y minus 2x. Our x is minus 1. So we have our points to be 0, 2 and minus 1, 0. That satisfies the inequality. And for the last one, which is y greater than or equals to 0, we have this to be y equals to 0. It has no solution to that. Now what do? We plot it on our graph. Now, where y is 0, we have here to be 1. Now, for the first part, we have 0, 2 and 3, 0. Where x is 0, y is 2. Where x is 0, y is 2. And where x is 3, y is 0. Now, where we have 0, 2, where x is 0, y is also 2 again. And where y is minus 1, x is 0. So then we join the lines together. So we have this. Now it is important to note that the solutions are contained in the unshaded part. So where we have this, where we shade this part away. So this part contains the solution. So this part is our 2x plus 3y less than 6, and we have this part for y minus 2x less than 2. So that is for simultaneous inequalities. And now our second example is solve graphically the simultaneous inequalities of 4x plus 3y less than 12, y greater than 0, x greater than 0 for integral values of x and y. So we have 4x plus 3y less than 12. We have y greater than 0, and we have x greater than 0. So we have this. Now it is important to know that this equation here is stable, this equation here is stable. So we basically work on the first one, where we have 4x plus 3y, which is equals to 12. So for our x and y, we need to look for our x and y. So where we have 4x, which is equals to 12 minus 3y. We have 4x, which is equals to 12, because here is where our x is 0. Where our x is 0. So we have our x to be 12 over 4. We have our x to be 3. Where we have x to be 3. So we have our 4x plus 3y equals to 12. So we have 3y equals to 12 minus 4x. This is 0. We have 3y equals to 12. And we have y equals to 12 over 3. We have our y, which is equals to 4. So our x is 3, y is 4. So we have 3, 0, 0, 4. Now we plot our graph. So we have 0 here, we have 1, 2, 3, 4, minus 1, minus 2, minus 3, and minus 4. So here we have 1, 2, 3, 4, 5. So where we have x to be 3, our y is 0, and where we have x to be 0, our y is 4. So we have this. Now basically we already have this. Now for our point where we have x is 0 and y is 0, now it is important that this part is where our solution set lies.
This part is where our solution set lies. Now we have x is 0 and y is 0. So where x is 0 and y is 0, we can have it to be this part, this part, this part, this part. We also have this part, we have this point, we have this point. So for the solution set which are shown by this mark, we can have our set to be 1, 0, which is x, and y here, which is this point. We can have it to be 1, 1, which is here, which is 1, 1. We can have it to be 1, 2, where x is 1 and y is 2. We can have it to be 2, 0, which is this point. Also, we can have it to be 2, 1. So we have it to be, we have different solution sets, a lot. If we continue checking it from our point, we have 1, 3. We also have it to the place. So through this, we are basically learning how to solve our simultaneous inequalities. And this brings us to the end of our class on simultaneous inequalities. Do subscribe to our YouTube channel, like and comment, and I'll be seeing you in the next class. Thank you.